In this video, we'll continue our discussion of regular expressions, adding a new tool called lookarounds. Lookarounds let you filter your matches based on what is around the match, such as before the match or after the match. So for example, let's go back to our statistician Trump tweet, which reads, "Our great American model was built on tough, very strong parametric assumptions, but far left elitists living in coastal tangent spaces out of touch want to throw these out, not on my watch." Now, suppose we consider the following task. We'd like to extract all of the words that are followed by one or more exclamation points. So in this case, strong, assumptions, touch, and watch are all followed by one or more exclamation points. So to do this, we can, of course, use our standard approach using groups, which we discussed in the last lecture. So let's take a look at how to do this. So here's our tweet in Pythex. Just moved over to Pythex here, and we're going to try this out. So let's go ahead and create the regular expression that we want. We know that we need one or more letters, and we can also include numbers if we like. Followed by exclamation points. So we can do this with groups by saying that the first group will represent the word and the second group will represent the exclamation points. So here I'll take one or more letters plus, there we go. So that gets me, that starts matching individual words. And then I'm going to say, okay, well, this is followed by one or more exclamation points. And now this gives me the desired result. I see that in my matches here, the first group has the words and the second group has the exclamation points. So I'll just take my regular expression. I'll bounce back over here to Python and we'll just try it out. So I'll do, first I'll import the regular expressions module again. I need to run the tweet. Okay, pattern equals R, and then in quotation marks, there's the pattern that I took from Pythex. Then result equals re.findAll pattern in the tweet. And let's take a look at the result. Okay, so this looks pretty good. I can see that I have matched the words that were preceded before exclamation points. And in doing so, I've also been able to actually retrieve the exclamation points themselves as the second group. However, I've kind of done more work here than I needed to in a way. I've done more computational work because I didn't particularly want the exclamation points themselves. I just wanted to check whether the words were followed by exclamation points. I don't want the exclamation points themselves. I just want the words that come right before them. So we can actually do this as well by using what's called a look ahead. So what a look ahead does is it says, hey, only count this match if the following criterion is matched afterwards, okay? So it's a conditional kind of operation. Only count this match if a conditional is found afterwards. So let's take a look at this in action. So my look ahead syntax is question mark equals. And here, what I do is I add my look ahead in at the very beginning of the second group. So I add a question mark equals in there. Now, what does this do? Now I have first ask in the first group, do I have one or more letters, A through Z, uppercase or lowercase? Then over here, I say, hey, if I do have that, then check whether there's one or more exclamation points afterwards. If there is one or more exclamation points afterwards, it's a match. Otherwise, it's not. So the incorporation of question mark equals before my one or more exclamation points ensures that I'm only going to match words followed by exclamation points, but I am not actually going to retrieve the exclamation points themselves. Notice that in my matches now, I don't have a second group. I only have one group. So even though it looks like I should be capturing two groups here, one of them is a look ahead group, and that means that it's not actually captured. It's just there to filter down to what I want. So if I go back to my Python notebook, so I can now do a different pattern. So this is what I added in Pythex. It's the same as before, but now instead of matching the group, I've added my look ahead question mark equals before I indicate the punctuation. And now again, I can do result equals re.findAll pattern in tweet, and my result is now what I wanted. I have only the words that are followed by exclamation points, but I haven't captured the exclamation points themselves. So this is a lot more compact, and it can make my code cleaner. So I won't have to go in later and filter out the exclamation points in any way. I actually have just been able to get exactly what I wanted here. So those are look-aheads. They filter your matches based on some criterion later in the string. We can also do look-behinds. So look-behinds behave very similarly to look-aheads, but they search immediately behind the match rather than immediately afterwards. So for example, let's consider the following string. So I'm going to replace my tweet in here. No more of that. So the string reads sometimes, but in parentheses, not always. The most important, in parentheses, or at least most intriguing, information is between parentheses. So suppose what we'd like to do is capture the information within parentheses. So in this case, we would like to capture but not always, and we'd like to capture or at least most intriguing. So that's our task. So to do this, we need to check two things. We want to check whether there's a parenthesis before our candidate match and whether there's one after our candidate match. So let's go ahead and make this happen. So for a first shot, let's try the following. So I'm going to match, so if I want the parenthesis itself rather than to use it as a grouper, I need to put it in brackets here. So in brackets, I get the literal parenthesis. So notice I've matched forward parentheses now. Okay, next I am going to need one or more text characters, A through Z. So there's one or more text characters. We can add a space to capture everything, to capture multiple words. So in this case, a space we can indicate either literally by typing a space or by using /s. Either of those are fine. Additionally, notice here, I want to match the entire phrase, at least most intriguing. Right now, I'm only matching the first little bit here. So I need to include the comma as well. So I'll just put the comma into my bracket. So now I have the full phrase in there. And then the last thing I need to do is just match the closing bracket. Okay, so this is close. So I'm matching the whole phrase. I'm in the right ballpark, but I want the words inside the parentheses and not the parentheses themselves. So how can I do this? Well, one thing I can do, and this would be a very natural first try, is that I can enclose the words themselves in a group. So here we are. Oh, and this in fact worked when I wasn't expecting it to. So that's a good thing to notice. Okay, so one thing we could do here is just match the words in the group here. And the reason this works is that I have not captured the parentheses themselves in a group. So I'm matching the parentheses, but I'm not capturing them in a group. And so I'm only getting out the match one as the words I wanted enclosed. So this, in fact, does work. Surprised myself there for a moment. However, this is not quite the cleanest way to do things. It's possible to be a little bit more careful here. So let's be a little bit more careful by using look-behinds and look-aheads. Okay, so the way that we get a little more careful here is we enclose our parentheses captures in groups as well. So now we're getting the behavior we don't want. We don't want to capture the opening and closing parentheses in their own groups. So we'll use our look-behinds and look-aheads. So to use a look-ahead, let's start at the end here. We'll look ahead. So we know the look-ahead syntax already. It's question mark equals. And we can see that now we no longer capture the parenthesis. That's what we would expect to happen. We instead condition on the parenthesis. We say, OK, if there's no closing parenthesis, don't find this match. Now we also need to add a look behind. And to add a look behind, we use almost the same syntax, just that there is a less than sign between the question mark and the equals. So it's question mark less than equals, and then we do our look behind. So our syntax here is we use question mark less than equals and then parenthesis and brackets. This says, hey, only show me the match if it's preceded by a single parenthesis. Then we have the match itself. It's just words and punctuation and spaces. Then finally, we say only show me the match if it is completed with a closing parenthesis. And this lets us capture our matches with a bit more fine-grained control than we would have if we had not used the look-aheads and look-behinds. So let's take that over to Python and just check that it works in Python. Here we go. So my pattern is here. It's just what I copied from Pyfex, and then result equals re.find all pattern and s. And then here's my result. Oh, and I forgot to initialize my string. There we go. So I've successfully pulled out the parts of the sentence that were inside parentheses. So as we saw in my little adventure in this example, it's usually not necessary to use lookarounds. Okay, these are usually not necessary. You can usually achieve the same task with groups or by simply not capturing certain parts of your match. However, lookarounds are very safe. They give you good fine-grained control of what you're doing. And so I do recommend them in cases where you need to check whether something comes before and after your candidate match. Not necessary, usually recommended when they apply. Okay, that's it for lookarounds. We have one more lecture coming up on regular expressions in which we'll do some slightly more advanced examples to illustrate the power of parsing unstructured text using these new tools.